Today, I'd like to talk about what we can learn from bones. The human skeleton can reveal basic information about both the individual and about the population. The first two things you want to know about any individual skeleton are the age at death and the sex. Sexing a skeleton is not possible until secondary sexual characteristics develop, or until after puberty. In other words, sexing a skeleton depends upon sexual dimorphism, which doesn't show up until after puberty. Generally, male skeletons are more robust. That is, males are larger and more heavily muscled, and this will show up in their bones. The more muscle you have, the denser the bone to support that muscle, and the more prominent your muscle attachments will be. Females, in general, are more gracile. They're smaller and less heavily muscled. Now, of course, this is not always the case. You know of men who are rather gracile and women who are rather robust. Here we can compare the skull's front and side views. You can notice the larger muscle attachments on the male skull. In the femurs, the male femur on the left has heavier or larger muscle attachments. So the best area for determining sex is the pelvis. And a number of different characteristics of the pelvis that I'll talk about include the size of the opening and the shape of the ilium or the wings, the pubic angle, and the sciatic notch angle. First of all, the male pelvis is narrower and the female is broader. That is, in the female, the ilia flare out more. The opening in the female pelvis must be large enough for an infant's head to pass through. In females, the subpubic angle is much wider and the pubic portion is longer, all part of how the pelvis itself is wider and broader. In females, the sciatic notch is wide. You can put your thumb in there and wiggle it back and forth, whereas in males, it's narrow. The second best area to use to sex a skeleton is the skull. In general, you can see that males have square chins and women have more rounded chins. The muscle attachments at the back of the skull and below the ear are larger on males because they're more heavily muscled or tend to be so. Males might have a large brow ridge with a sloping forehead, whereas females would have a smaller brow ridge and a more vertical forehead. And the angle of the jawbone also differs. So the first thing you might notice are the larger muscle attachments in the male, both at the back of the head, at the nuchal crest, where the neck muscles attach, and at the mastoid process, where also side neck muscles attach. Here you see some of these muscles attaching to the bone. So the bigger your muscles, the bigger the attachment point on the bone. In males, the brow ridges above the eyes may be more pronounced, whereas in females, the frontal bone may be smoother and more vertical. In males, the chin tends to be more square, and the angle of the jawbone is acute at the back of the jaw. Whereas in females, the back of the jaw tends to have a wider angle, and the chin tends to be rounded. Again, square chin in males, rounded chin in females. Let's move on to aging a skeleton. You can get a pretty good age for young, but from about 25 to 30 years onward, the estimation of age depends almost entirely on degenerative changes. I'll look at 3 different measures for aging a skeleton: tooth eruption, epiphyseal closure, and pubic symphysis roughness. Let's begin with tooth eruption. Humans have deciduous and permanent teeth that tend to erupt at known ages. Here is a cross-section of a 6-year-old child's mandible showing that the deciduous teeth are erupted here, but the permanent teeth are still inside the jawbone and haven't yet pushed up through, pushing out the deciduous teeth. We have 20 deciduous teeth, which tend to erupt between 7 to 24 months of age. Now, of course, we've all met some infants born with teeth, but generally speaking, these teeth don't come up until 7 months old at the earliest. And between 2 to 6 years old, the roots ossify. That is, they become hard. The permanent teeth erupt between 6 and 18 years of age. However, the third molar may never erupt, or it may erupt late. Tooth wear is not reliable for aging. Tooth wear depends on your diet. If you eat a lot of sand, your teeth will be worn. You're not deliberately eating sand, but let's say that you're grinding food on sandstone. You get sand in your teeth and it will wear down your teeth. And also if you use your teeth as tools, it can wear them down. The second way to estimate age is to look at epiphyseal closure. A child has 300 bones, and yet an adult has only 206. How is that possible? Well, many bones grow in sections. That's how we're able to get larger as we age. When growth is complete, the growth plates between the sections ossify or turn to bone, and the sections become one bone. The long bones grow in 3 sections, a diaphysis or shaft, and the epiphyses, 2 ends. So here's another Latin-based word, epiphysis, singular, 1 end, epiphyses, 2 ends. You can see that between the epiphyses and the diaphysis is an epiphyseal plate, and this is where growth takes place. During the first 16 to 18 years of life, we more than triple in length. This picture illustrates a femur or a thigh bone from a newborn to an adult. You can see that it starts out with separate diaphysis and epiphyses, and growth takes place between these 2 types of bone. But as you age and growth stops, the epiphyses unite with the diaphysis and become one bone. Thus, an adult human has 206 bones. So growth takes place at the growth plate between the epiphysis, the end of the bone, and the diaphysis, the shaft of bone. And when the epiphysis unites with the diaphysis, growth stops. Premature union results in dwarfism. Failure of union results in gigantism. Here I show you the point at which the epiphyses unite with diaphyses on various bones in the human body. You can compare your age to these ages. The last one to finish growth is your collarbone. The skull also begins in separate pieces. The infant's head has fontanelles also, which are holes between these plates of skull. The fontanelles eventually fill in with bone, and where the bones meet, they form sutures. Thus, the head can be much smaller and able to pass through the birth canal. The third way to estimate age is to look at pubic symphysis roughness. The pubic symphysis is where the 2 pelvic bones join in the front. Now, during childbirth, this area softens, the cartilage between these 2, and they pull apart. 10 phases or changes have been established in pubic symphysis roughness. You can see that they start out at 18 to 19 years of age in males is very rough, and by 50 years and older, much smoother. So to summarize, the first two things you want to know about an individual skeleton are the sex, and we look at this by looking at the pelvis. Female pelvis is wide, the male's is narrow. The skull, males tend to have bigger brow ridges, bigger muscle attachments, and a more square chin. And just the general aspect of the entire skeleton. Males, generally speaking, will be more robust and females more gracile. We also want to know the age at death about an individual skeleton. And the three measures most used are dental eruption, that is based on the principle that teeth erupt at known ages, epiphyseal closure, in which we look at the time periods at which different diaphyses and epiphyses tend to unite, and pubic symphysis roughness. Now, the more of these that you can put together that will agree, the better you feel about your assignation of sex or age for that skeleton. But many times you just simply can't tell. What else can we learn about an individual from a skeleton? I have a long list here that I'll go through, but this starting with stature or height. We often use the femur to estimate the stature of the person. We can also see injuries to bones, especially if they've healed. We can see that the person lived past that injury, or whether they did not live past that injury. Here's somebody who did live and their badly broken femur healed. If the cause of death affected bone, we can see that. Here obviously is a fatal skull fracture. If diseases affect bone, we can see that. Syphilis, for example, leaves quite a large signature on the skull. Not all diseases have different signatures, so you might be able to say that they look diseased, but not be able to say what disease it was. We can also look at general health and nutrition, and in particular, we might be able to talk about what diet the person ate, because you are what you eat. The isotopes that you ingest become part of your bones as well as all your other tissues. For example, we've used the heavy carbon isotopes C12, C13, and C14. If you recall, C14 is unstable and therefore has been used to date organic items. But C12 and C13 are stable. Whatever ratio of these that you take in your diet during your lifetime will still be there tens of thousands of years later and can be used to tell us about your diet. Plants have different photosynthetic pathways, which result in different ratios of the carbon isotopes. For example, maize is a tropical plant that produces carbon-13, whereas wheat is a temperate plant that produces carbon-12. So if you ate wheat but no maize, or maize but no wheat, we could tell from the ratio of C12 to C13 in your bones. In addition to carbon, we've looked at other isotopes and elements. For example, heavy nitrogen isotopes are very interesting and useful. Or the ratio of carbon to nitrogen can tell us whether somebody was carnivorous or vegetarian. For example, a nursing infant will show up as carnivorous. And elements such as strontium differ geographically from one place to another. So the ratios of these elements could also tell us where you spent your childhood versus where you lived when you died. Bones may also show cultural practices. Was the child wrapped onto a cradle board when they were growing up? That will affect the shape of their skull. Did they have other cultural practices, like drilling and putting gold into your teeth? Sometimes we might be able to see genetic relationships. For example, this picture shows parietal foramina on both sides of the sagittal suture, that is, on the skull. Foramina is just a fancy Latin word for holes. And if you know the ethnicity of the person, you could perhaps reconstruct their face. So what can we learn from a population of skeletons? One of the basic things we want to know is the paleodemography, that is, the basic population statistics. This allows us to understand the structure of the population. For example, what was the mean lifespan? What is meant by mean lifespan? Well, it means the age at which half of a cohort have died, but half are still alive. So, for example, if the mean lifespan was 50 years, and among a cohort of people born in 2000, by 2050, half of them would be dead and half would still be alive. We also want to know the sex ratio. A second thing we might learn from a population is the paleopathology, that is, what diseases were prevalent. We know that the higher the population density, the more infectious diseases you can see. Let's think about the pandemic right now. If we had just a very small population and everyone had gotten the COVID-19, then there would be no one to pass it on to. But if you have a large population and only some people have the disease, then it can be passed on to other people and the disease itself can continue to live. We can also look at the general health and nutrition of the entire population. What patterns do you see at the population level? And what can that tell you about human behavior? To analyze either your individual skeleton or your population, you can compare it to others. So you can compare your population to other populations, looking for similarities, differences, or change through time. Or you can compare your individual skeleton to the population to see whether that person was normal or unusual. What can you learn from the grave? Well, we'll cover this later, once we start to see graves in the fossil record. But I'll give you a hint. We might be able to talk about that person's ideology or religion. We might be able to talk about the social structure of the population, or the social status of the individual, or the items buried in the grave might speak to what sort of trade was present at that time. To summarize, two major things you want to know about each individual skeleton: sex and age at death. How do you sex a skeleton? The number one way is to look at the pelvis. The number two part of the skeleton is the skull. To help those along, you would also look at the general robustness. How do you age a skeleton? I talked about 3 different measures: tooth eruption, epiphyseal closure, and pubic symphysis roughness. I also talked about other things that you can learn about an individual. And what can we learn from a population? Well, the first thing we want to know are the basic population statistics, that is, the paleodemography. We also want to know the paleopathology, that is, the disease prevalence. And we want to know about the general health and nutrition of that population.